pictures throughout here will be from Afghanistan. So why me? Why am I here? Well, cartoons are always a good way to learn. This cartoon came out in 2014. It was actually in the Kansas City Star, which surprised me because I didn't think they were paying much attention to this issue. So what left-wing, bleeding heart liberal group is going on about climate change now? And I'm the guy in the back in the uniform. The knuckles aren't, they're not as hairy as the picture, but that's it. What had happened was the United States Department of Defense had just issued its climate change roadmap. And the national security strategy had been issued that said climate change is a critical national security interest. Climate change is real and the impacts are severe. So those two things caused this cartoon to be produced. And I always make the joke, these are the folks that I usually talk to, civic groups that have developed in there. That's good, but that's not fulfilling. We need to be talking to a broader range of people. And I always so joke that this guy here, I don't know, big business, supposed to represent that, but I know he's got a brother and one of them lives in Wichita and owns a big industry and they're worth $90 billion because they have a fight on climate denial for the last 15 or 20 years. Those are the people we need to be talking to and having a report. If I was king for a day, I would have a big conference, and half of it would be the people that are interested and understand, and the other half would be the people that believe it's not real. We need to be talking together. So hopefully, if you know those kind of folks, I hope some of those folks are in the room today. But the Pentagon has been involved in this a while, and you'll understand why as we go through here. Now, I usually give this as a very civilian-oriented, but this time I decided I'm going to change it. Today I'm going to be the general, and we're going to do this military style. So if we're doing this military style, first thing we have to have is a mission. You always start with a mission. It needs to be well-defined and achievable. This is well-defined. Achieving is very, very, very hard. Develop a strategy for national security, for the challenges, the threats and risks posed by key environmental issues, including climate change. Climate change is the one that has brought the focus to this, but I'm going to introduce you to some others that are pretty scary too. Ones that are very familiar here in western Kansas, by the way. Then you go to an end state. If you're going to have a military mission, you got to have to know when you won and you can go home. That's really, really important. We haven't been very good at that lately in pretty much all our missions. We write a mission, but we don't end up with an end state, or the mission is not one that's achievable. We fear that this could be the case here when we're dealing with environmental security issues. But what I want to get for today is for you all to think critically about the evidence that I'm going to present, the ideas that we talk about, and start developing your own understanding and your own ideas about how we should go about solving this problem. And that's a long-term thing, but we have to start with these thinking processes. Now, in the middle, we have our ROE. These are the rules. You will follow the rules. We have a V. See, we all learn strategy from an old German guy named Clausewitz. We teach him in every military school. It's a huge old book. It's boring as I can't imagine how to describe it, how boring it is. But it is the way we organize and think about and develop the end state from a mission and go about planning operations. So, like I said, I'm talking to the students. You others are welcome to listen in. But my focus is on our students today because they're going to live with the consequences of that. I'm going to be long gone before the real impacts, as I perceive them, are going to take place. They're going to live with and struggle with the consequences, so they need to be primarily our focus. Climate change, environmental security, has no political affiliation. It is not property of any party. It is a scientific discussion. Just the facts, ma'am, I put on some of my slides. Next, I am a kind of a pragmatic guy. You heard I had 3 engineering degrees. We're practical kinds of people rather than theoretical. So I have 2 case studies in here. When we get to the case studies, we're going to have some small interchanges. I don't want you to sit here the whole time. So the interchanges have to start with student discussion, though. Then we can follow along. And then number 4, all ideas are considered. It's not just those people who believe climate change and some of the information. When we do military thinking, we take some of our brightest minds and we tell them, you're the bad guys. You look at our plans and you pick them apart and you figure out ways to defeat us in our planning. Our best and brightest, that's what we use them for. We call that red teaming. So if your ideas can't stand up to that scrutiny, maybe it's not a good idea. That's the thought process is there. So red teaming in this process is encouraged. If you're trying to really do critical thinking, you're doing some red teaming as you go through these things. So those are our rules. Another way to go about solving problems is develop key questions. That's the scientific method. Here are my 3 key questions, and we'll go through those. But I want to introduce you to something else. Who's General James Mattis is now serving as the Secretary of Defense. Everybody's heard of him, please? Yeah. He's been doing pretty well in an otherwise chaotic condition. In his testimony to Congress to get the job as Secretary of Defense, he stated, climate change is impacting stabilities in an area of the world where our troops are operating today. And he went on expounding about why he thought climate change was a key security issue. So one of the questions we could pose is, why did James Mattis believe that? Why did a 4-star General Marine from his military experience believe that to be true? I think we'll get to an answer there. And as I've already introduced to you, we can't jump into climate change without introducing you to the concepts of environmental security. This is where I have spent the last years of my research agenda in trying to understand what in 30 years of kicking around the world, 51 different countries, usually in a place that needed humanitarian operations, we were doing peacekeeping operations, we were doing nation rebuilding in some of the most dire circumstances. All right, you saw what was going on. People were dying. People were impoverished. But why? What? Just bringing some food and bringing some medicine doesn't solve that problem. I did the Rwanda mission in 1994. We had 1 million people in Goma, Zaire. 5,000 people a day were dying when we started the mission. But why? What are the fundamental reasons behind that? Those are buried in environmental security. So I want you to understand that concept. I will let you read that. The environment is changing, is always changing, but there are human-induced changes in different parts of the world. And in many places, that denies people the ability to sustain their basic human needs. That's the whole principle of a huge amount of science, as I boiled it down to, and from my experience in around the world. People aren't able to obtain the food, the water, the energy, the basic health that's sustainable. And when they don't have that, most of those places, they have few choices. Like I said, I started in 1993 at West Point. But the study of environmental security had gone on from the 1950s, 1960s, and beyond. A group of scientists at places like Harvard and Yale and Princeton, mostly political and social scientists, were studying this concept. I will read this one. I don't usually, but this is profound. National security is not just about fighting forces and weaponry. It relates to watersheds, croplands, forests, genetic resources, climate, and other factors that rarely figure into military experts, the minds of military experts and political readers. In 1986, based on research that was going on in the 50s and 60s and 70s. Now, I always add one here. From the military science side, there's a guy named B.H. Liddell Hart, a famous strategy and military historian from World War I vintage. And he had something that also influences this discussion. He stated, in general, the only thing harder than getting a new idea into the military mind is getting an old one out. And that was the problem that I faced in 1993. Getting the idea of environmental security into minds that already had assured themselves that it was all hooey. And that was the prevailing thing in 1993. Look what James Mattis said just last year. The prevailing minds have changed, but it's taken a while. So, here we are, BCK, before Chris King. That's me. 2.5 billion people on the face of the earth when I was born. We're now at 7.3 billion, and we don't know exactly what the projections are because there are many. 9, 10, 12 billion people on the face of the earth. 2 questions. Do you believe that 9 billion people have an influence, have the ability to change our environment? That's one question. Just think about it. And number 2, and more germane to this discussion, of the 7.3 to 4 billion people on the face of the earth right now, in Maslow's hierarchy of human need, where do most people spend their time? At the nirvana level or chasing basic human needs at level 1? Right down at the lowest level. And that's what my military experience taught me. The places I was going, those people were struggling on a day-to-day basis to get clean water, to maintain their health, to find some food. And for you young folks, and by the way, their values were pretty much the same as ours. They loved their kids. They wanted to take care of the people. They were polite and cooperative with their neighbors. They have the same values we do, no matter what they look like. But they aren't able to sustain their basic human needs. And that's the struggle they face. And that's the basis for environmental security. Those people that are at most at risk. And as you will see, it's really going to be risky when dramatic changes take place. I killed that thing, yeah. Thank you so much. So, the science of environmental security, all of these are environmental security threats. To me, and the one I started with, water is still the scariest. The national intelligence community says over the next 20 years, water is a scarce resource. It's going to threaten billions of people. You know, 2 million people a year died from dirty water. More than 1 billion get sick every year from dirty water. The 5,000 people a day that were dying in Rwanda when we got there, it was cholera, dirty water, contaminated with sewage because they were just so packed together. Clean water, oceans, air, climate change, but other factors. Loss of arable land, deforestation. In different places in the world, each of those is an environmental security risk and threatens people. We don't have time to discuss all this. I teach classes this in graduate level courses and undergraduate courses in depth. And it takes a whole semester to get through all of this in a coherent way. So let's do a case study real quick. This is the Nile River Basin, one of the big major rivers of the world. It flows north to the Mediterranean Sea. It starts down in tropical Africa. 13 countries are served by it, but really only 6 or 7 of them draw major water supplies from the Nile River. Over here, I have put the approximate rainfalls. So it goes from 40 to 80 inches per year in the Congo, Uganda, Rwanda, Burundi range. That's tropical Africa. And by the time it gets up here, the rainfall is nothing. But most of the people, as you're going to see, live here. And here are the yearly flows in the Nile. It's a very difficult number to come up with. It's somewhere between 140 and 180 billion cubic meters of water a year. But we all know it doesn't come in a nice even, you get the same amount every month. They have a strong amount of water seasonally in the summer period, and in the winters it gets very dry. Now I just put this note down here for later discussion. So, first of all, strategic standpoint, Egypt is one of the key partners that we have in that part of the world. The big stressors right now is Sudan and South Sudan, where we still have war. Eritrea is constantly of concern. And Ethiopia here is a struggling nation. Water demand and population in the Nile River. So let me go to the bottom here. Right at this period of time, 265 million people to 280 million people. It's gone up. It goes up pretty fast there, by the way. And they use about 170 billion cubic meters of water a year, which is about the whole supply. By 2050, not that long, at very conservative population growth rates that are already going on down there, 700 million people, nearly 3 times the population over a very short period of time. If water demand stayed the same, it would demand more than twice the amount of water that's in the Nile. My critical thinking. Give me 2 problems that you see created there. Come on. I'm not going to let you off the hook. Your teacher's grading. I don't know. How do you threaten kids you don't know? Nah. They may have an idea. Just pop up with something. What's scary about that? What? Unsustainable. You blinked. Blue shirt. They got to get water from somewhere. True. There's where I wanted to get to. Very good. So they move. Where do they go? We say you've got 2 choices in these kind of situations. Flight, fight. Big source of conflict right now, Ethiopia, here, which has the Blue Nile, 75 billion cubic meters, is damming it up to use it for its own purposes, to generate power, to water arable lands that right now are not arable because they're dry, and to support a very rapidly growing population. Egypt, I've had 2 students from Egypt and 1 student from Sudan that studied at the Command and General Staff College. You probably didn't know it. We have 8,000 graduates who are international students. 28 of them have been heads of their own country, like Rwanda. The head of Rwanda is a graduate of the Command and General Staff College at Fort Leavenworth. I taught his son. His son was brilliant. Spoke 6 languages already. Just brilliant, man. We get too cavalier about being American and being well educated sometimes. My South Sudanese student, he spoke 5 languages. And he'd been in the People's Liberation Army of South Sudan since he was 12 years old. He was a child warrior fighting for liberation of his country. South Sudan says we have to reach an understanding, develop a water resource management program. Child warrior wrote that about understanding the problem. Brilliant. The Egyptian soldier said, we'll go to war for whatever we need to for all the water in the Nile. Egypt is the Nile, and the Nile is Egypt. That's in their history from 5,000 years ago. Is this a strategic problem for the United States? Absolutely. If we lose Egypt as a partner in the Middle East to continue to develop the discussions in the Middle East, we're dead in the water, because everything's tied around the relationship that has been built up there with Egypt as a centerpiece. Another thing to think about, what if everybody in the Middle East had enough water? Would we be able to get closer to a peace resolution? Nearly everybody in the Middle East gets their water from somebody else. Syria, Lebanon, Iraq get all of their water from Turkey. Why do the Turks not want the Kurds to have their own country? Because all the water comes from where the Kurds live. That's the kind of strategic problems that these kinds of environmental security issues create. And oh, by the way, we're getting to it now. Climate change predicts that in the dry areas, there'll be less water. I don't know how you get less than you do at Aswan, Egypt. Aswan, Egypt has a weather station. The average water at Aswan, which is where all the water comes from Egypt, goes through. The average annual rainfall is 0.00 inches. It rains a little there every 4 or 5 years, but not enough to measure. Strange irony. But that's the world we live in, guys. So, we got to spend the rest of the time on climate change, because that's what I promised that we would talk about. In one way, this slide has absolutely nothing to do with climate change, but I just like it. I have this great fear of snakes. The other way I look at it is we're on the other end and we're looking through and we see a little light. And we don't know what we're about to get into as we crawl down that pipe to get to the end of the tunnel. This could be the future for climate change. Okay, I'm going to baseline everything. So I don't know that anybody in here has ever studied climate change at all, so I'll make that assumption. We have been teaching climate science for hundreds of years in geography programs. Now we call them in environmental science programs. But we understand basically there are only 3 causes that cause the climate to change, and it changes naturally all the time. But it changes naturally all the time at relatively slow rates compared to human existence. We talk about that as geologic time. Things that go in thousands and tens of thousands and hundreds of thousands of years, as opposed to things that go next week, next month, and over the next 10 years. 10 years doesn't mean anything. And that's one of the issues we need to address. The sun's energy varies, we know that. The orientation of the Earth to the sun, both in the tilt and the distance, that varies. But look, it varies over 100,000 years, over 40,000 years, and sometimes as fast as 19,000 years. They change very, very slowly. And the influence that we refer to as the greenhouse effect changes based on the concentration of those greenhouse gases in our atmosphere. They have the ability to absorb the reflected long wavelength heat that has hit the Earth and is reflected back. That's what keeps us warm. The greenhouse effect is a good thing. A heightened and enhanced greenhouse effect is what we're talking about as the problem. So, we have the natural changes and we have the human-induced changes, because what we're doing right now is adding significantly the concentration of greenhouse gases that are in our atmosphere that are known to absorb that extra heat. So instead of the heat going back out into space, as we were taught it does, a little bit more of it's being absorbed and maintained in the close atmosphere. Those are the only 3 things that'll do it. These cycles are set except for the energy from the sun, which is very sporadic. But it doesn't last very long. It's not hundreds of years. It changes over days and months and not much more than that. We have measured those. We have calculated in and designed the thermodynamic and the physics that says what those changes from distance and orientation would be. So we have, over the last 25 years, we have learned a tremendous amount about how our system works. The hard part is this part up here, because there is a thermodynamic system, there is a chemistry system, and there's a biologic system, all acting together. So if you get a little bit more CO2, that enhances the growth of biologic system, that changes the chemistry because it's warmer, and things go faster in chemistry when it's warmer. That gets complicated. But we're even getting a pretty good handle on that. Now, we're not talking about whether global warming is real. It's real because it's been measured. Here is just some of dozens of pieces of data that I have that said over the period from here to current day, the Earth is warmed. And we'll show you the specifics of that. The 10 hottest years, it's now the 12 hottest years since 1998 have occurred just recently, and they continue to pile up. And then the other thing is showing the relationship between the warming that we're seeing now and the amount of carbon dioxide that's in the atmosphere, which is the key culprit. Carbon dioxide is produced by the burning of fossil fuels. Natural gas, coal, gasoline, oil, anything, wood, any of those things that you burn produces heat, which we recover for energy and produces as byproducts water and CO2. So the atmosphere has warmed this much. Now, I skipped one briefly. One of the things, and I think that we do badly as part of those that are representing the idea, we talk about, my God, this is the 10 warmest years since we've recorded. Recording started right there. We had in 1880 probably enough weather stations that we can say we know approximately how warm the Earth's atmosphere is. Before that, you didn't have enough data to say what it really was. What we had was scientific evidence developed from all kinds of different ways, from looking at tree rings to doing ice cores, to doing carbon dating and all of these other kinds of things. We are very cavalier in taking recorded data and making it sound like it's the whole thing. It's not. It's only since 1880. And that is that in geologic time. And I think that's a misrepresentation that we ought to try to avoid. We ought to identify where we're dealing with. Let me show you. This is scientific evidence here. This goes back 800,000 years from ice core sampling, recording both the temperatures that were there and the amount of carbon dioxide that was in the atmosphere at that time. That is evidence developed from the best science that we have, but it's not the recorded data. And we misspeak when we use some of that stuff. All right. So, here are the changes. Yes, the atmosphere is warming, but the secondary impacts are 90% of the heat goes in the ocean. Thank goodness. If that heat was in the air would be tens and more warmer. It's heat capacity. Water's got 7 times the capacity to hold heat that the same amount of air has, which causes the ocean to warm too, which has all kinds of changes in the fish biota, killing off all of the, what am I thinking of? Come on, folks, help. The coral reefs and doing damage to the coral reefs. The cryosphere. We have lost, as a strategic thing, we've lost the ice on the north part of the world, which from the United States and Canada used to be a nice thing. We don't have to worry about defending the Arctic Ocean and the North Pole. Now now you can navigate through there. The range of problems that creates for us as a military problem are significant. Who owns the resources? What are the laws that apply up there? These are all new, strange things that causes. But the most significant thing about the cryosphere is how it affects the water balance. And we'll go over that with our second case study that we're going to use. Arctic sea ice. When we talk about losing things in 3 to 5% per decade, that's light speed in geologic change. We should be talking about things that are 1/100% change over hundreds of years. We now have periods, and they measure at 30 September, where you can completely navigate across the North Pole. And in our recorded history, that hasn't been around for hundreds of thousands of years. And the loss in the northern hemisphere of snow cover, which is the major water resource management process for much of the world, including the United States, is in 1.6 to greater percent per decade. It is these rates of changes that drive scientific thinking to say this cannot be natural. It is natural plus human-induced change. That's the only answer that can be derived from all of the data that's developed. Primarily, that from the data, the two primary greenhouse gases have not reached the levels that we have today for at least 800,000 years. Because we are 7 billion people, and we are consuming carbon-based energy that has been stored for millions of years, and we're consuming it at very, very high rates. That's just so. Here is the big finish for all of this discussion of why scientists believe more than 50% of the climate change of today and the drivers for what it's going to be like in the future are human-induced. We now have very, very large programs that try to model all of the three changes, and they produce an answer that says the temperature should be right here. And the temperatures are really right here right now. And the delta is driven by this spike in the greenhouse gases. That's what the science that we have today. Did we have this in 1990? No. We did not have this level of understanding of how the processes work together. A lot of effort plus some big-time supercomputing coming to bear have made those changes over the last 25 years or so. But that's where we stand today in the science. See, our problem is we just haven't learned to conserve like the rest of the world. Saw that in Africa. I had to have the picture. Why is this hard? I don't want to trivialize that. Because we're 330 million plus people. And we have needs for energy for transportation, industry, where we live, and electrical power. These needs aren't going away. For America, we've stayed about the same for the last 20 years in our overall power supply demand. Demand has stayed flat. We have increased the amount of renewable energy. This is going down some, and we have relied on these as our primary sources. And you can see how intertwined it is. So we can't trivialize that all this can go away and we're all going to be happy going back living without that energy. That's not happening. We're looking for solutions that learn how to balance all this out while reducing the large percentage that comes from that. That's kind of the conceptual model of how the problem gets to be. To me, this is just now a personal opinion. A lot of this, like electric power, is convertible to renewable energy very, very easily with technologies that we've got now. some component of that. This may be the more difficult one, and I'll admit it. That little, right there, 1 gallon of gas that'll push my little Toyota hybrid down the road 50 miles, that's pretty hard to beat. That's a very, very efficient system. Drive 3,000-pound car 50 miles on that much. It's nice and compact. It's easy to move around. That's a tough one to break. Plugging your electric car into something that's burning coal in western Kansas is not solving the problem. We got to recognize those kind of complex interrelationships that are there. I will never trivialize those because that's the real problem we got to solve. People, I love them. They've got their cars and they plug it into the thing. 80% of the power is lost before it got to the plug. Between burning coal in western Kansas and shipping it through what are really archaic electrical power grids that we have in America today. It actually may be better to burn the little gallon of gas. So we got to have better solutions is what I'm saying. So this is how we spend our energy compared to the rest of the world. See, this one makes it a little tougher for us compared to many other places in the world. Okay, so I'm supposed to talk about the security impacts of this stuff. When we look at this, if you look at the DoD climate change roadmap I told you about, they talk about there's an internal risk, sustaining how we live in America, getting that power that I just showed you to America while not suffering the impacts of climate change, such as sea level rise that may flood key military structures, key civilian structures, extremes in weather that are coming because there's more energy in the system. And then from a national security external standpoint, the risk to other parts of the world where more and more people cannot obtain their basic human needs, back to environmental security, and the threats that pose to our allies in different parts of the world and parts of the world where 7 billion people are living that we cannot afford to have turn into total chaos. Those are the external security risks that we're looking at. This is what General Mattis was talking about because he has had charge of looking at a part of the world and saying, what are those key threats to me and the part of the world the president has assigned to me to watch over. And in those parts of the world, environmental security driven by climate change was scary to him. At one time, that was the biggest risk we had in the Pacific theater. North Korea has changed the paradigm there. And now the critical concern is the nuclear threat in North Korea. But climate change still from the long term has to be considered as one of the threats we look at in the Pacific theater. That's the way security strategic thinking goes. It's a little easier to understand if I give you a case study, though. A case study. This is the Tibetan Plateau. The Dalai Lama lives there somewhere. I make the joke that the Chinese don't dislike the Dalai Lama at all. They just want all his water. This is, in my view, the best water resource management system ever designed. And we didn't design it. I'm an old Corps engineers guy. I hate to admit it. I didn't put up dams and levees there and make it into the great water resource place I can go fishing. It is a natural system driven by snow and ice cover here that melts during the summer periods and releases water into the 7 major rivers of the world. And it serves 3.2 billion people. Nearly half of the world survives off this one watershed. And remember back to the data, we're losing 3 to 5% of that water per decade. So in 30 years, 10% of the water's gone. And oh, by the way, some of these are some really fast-growing countries. So we're back to the same problem we saw in the Nile River Valley, but 7 rivers, the biggest rivers in the world. Strategically, what is my issue? When I look at this map, what is my strategic focus and issue? One word first. Bingo, China. China is the biggest army in the world. 1.3 million people under arms at any one time. And if they need to put 10 million under arms, they'll do it tomorrow. What are other issues there? Come on, students. Next one's got to come. What? Big issue there. There was a report that came out this week that said China is now using water as a weapon. Against whom, would you guess? Looking at the map. What? India. Second largest army in the world is India. Over 1 million people under arms. And again, with 1 billion people, if they need to, they can make more. It's not a problem. Pakistan, sixth largest army in the world. Those three are all nuclear weapons capable. And that's capable of delivering them any place. We're worried about North Korea, but there are other people that are already carrying packing arms. And those are three of the biggest. 11th largest army in the world, you wouldn't believe it, but it's Myanmar. 13 is Vietnam. It is a very militarized part of the world. And it's losing its water supply. If it continues, these rivers become ephemeral. They don't flow in the summertime. And during the winter, they have high flood rates. So millions of people live in these low-lying areas already. So they're flooded out during the spring periods and the spring rains and the melt-off, which occurs at higher rates. 35 million people are supposedly going to be displaced in Bangladesh by 2035. Where do they go? Well, you'd say India because it's completely surrounded by India. But India doesn't think so. They've already built a fence around the whole country. India built a fence completely around Bangladesh, and they have their army on the fence, and their army has shoot to kill. Their rules of engagement is if somebody tries to come in that's not supposed to, you may kill them. And they do. But there's 175 million other Bangladeshis. So it's a crowded. They live here because they're the poorest people in the world, and they're living in the margins already. When a cyclone comes or a major tsunami comes, 100,000 of them are killed every time. It goes over and over and over again. Please. Okay, which ones? Please. Okay. But there have been hundreds of thousands of people killed in floods there. Okay, please. Okay, yes. All right. Would you support? Bangladesh is a very high risk for the impacts of climate change. Okay. Okay. Good. That's the big picture. If I got some facts wrong, I will not.
The poorest people in the world? Well, no.
No, I didn't say that.
Right up there.
I didn't. I say they have some of the poorest people in the world. Right. They live in the margins at the low-lying areas because they cannot afford the better lands in Bangladesh.
There is in Bangladesh.
Yeah. There's.
So anyway.
Okay. No. Good.
Sorry to interrupt, but
No.
I guess I'm kind of tired of people using Bangladesh as a case study in all of these.
Well, I use Bangladesh because a good friend of mine was the chief of staff of the army there, and he's provided me these data. Because he has to respond to those things when the Bangladesh army has to go out and try to do the work that armies do, which is when you have a humanitarian operation. I mean, why did we get beat up on Puerto Rico? Because the army wasn't there soon enough.
On the border shooting people also.
good? Okay, let's move on. I got to get through this right now. So what I want to point out is, for each one of these boxes, that's a climate change impact. And each one of those has a key impact to humans. And I'm going to blow this up a minute, so you don't try to read this. So, global warming, extreme temperatures, drying, extreme precipitation, changes in overall precipitation, snow and ice cover, damaging cyclones, and sea level rise. Each one of those is an impact from global warming. Then that impacts humans. And then from that, we study it for what are the security and defense risks associated with that. So, for the case study we're looking at, the scariest one is the loss of snow and ice cover and how that impacts the Tibetan Plateau. Loss of snow and ice cover, main change is stressing water resources, increased rate of warming, and flood and droughts, and sometimes in the same places. So as a defense and security issue, I look at more humanitarian operations in that part of the world. They're very difficult for us in that part of the world. What we mainly do is move large-scale logistics. We move medicine, we move food, we move water, we move people around. We do refugee relief, we do border security, we do epidemic disease control when we go to this kind of catastrophic event. Each one of these are challenges for us. They're challenges for the military in places like India, Bangladesh, and even China. And so from a security standpoint, it drains our military resources from our primary missions, our primary defense missions. And it increases the requirement. What did the disaster in just Puerto Rico cost? We're estimating $8 to $10 billion. We haven't even thought about how much the military has to spend to do all of the work that we do. So what's next? And the question is, how do we get out of this? We don't know until we know what we're going to do about reducing the level of greenhouse gases, is the bottom line to this. So what the UN has done is, it says, so what if we're able to reduce it a lot? What if we're able to reduce it some? What if we continue to produce greenhouse gases at high levels? It did alternative possibility analysis. And here are the results. Greenhouse gases at the median range, the Earth continues to warm to 2100 at least, and reaches well over 2 degrees centigrade across the globe. Many places in the world will be 5 or 6 degrees more because the land heats up faster than those things that are close to the water, and the old climate controls that you study are still in place. At the worst case, it would be a global increase in temperature of over 11 degrees centigrade, which makes many of the places in the world uninhabitable. Makes places in the United States uninhabitable. Inside the territory, in the middle of the lands, because that's what heats up the most. So where are we now? The Clean Power Law that was just repealed was going to reduce our emissions from the United States by this much. Clean cars, which has been proposed to be canceled, would reduce it this much, and these others would have to be reduced this much to get to the Paris goal that we had from the Paris Climate Change Summit. So, like I said, we have been pretty much common here for a while. We're at risk now for at least half of what we've got, based on the current. So, here, now I got to quit. Internally, the impacts for us in the United States are going to be impacts on water resources, energy supplies. My biggest fans right now have been the people from the agriculture community. They already know something's changing. They're trying to figure out how they're going to respond to it. Changes in agriculture, how much you produce, what you produce, would be significant impact in the United States. Ecosystems, a scary one is human health. A warmer world expands the range of many of the epidemic diseases, particularly vector-borne diseases. We're seeing that now with some of the viruses that are coming into the United States that haven't been here before because it's warmer and they are migrating out of where they have been before in the hottest, wettest parts and migrating north and south. But the biggest overall is the impacts that it has external to us on billions of people around the world who are less and less able to sustain themselves, maintain clean water, food, avoid disease. The least developed countries are the most at risk. That's the biggest agreement. And oh, by the way, those are generally the ones that have the highest population growth rate. So it's like a compound interest that they are paying in the threats that they pose. The New York Times says the United States has surrendered its leadership in the war and the economic opportunities that the new world, the new energy systems will be required. That was March 2017. What are your questions, quickly? Comments. And good comments back there. I'm sorry that the gentleman left, but that was a good comment. He had another class, but yeah, that's this slide. I wouldn't even gather it towards that. We haven't gotten that. The best news I have is China has significantly started to address this. They have closed a tremendous number of coal-fired power plants. Their problem is human health. They're gassing themselves right now. We just have to look at those things, and each one of these alternative futures produces a different answer to your question. The answer is we're going to have to go to something close to this to be able to bridge through this gap without a significant amount of pain. The United States is going to be able to adjust a lot, not to everything, but to adjust a lot, because we have the capacity to mitigate and adapt. But many, many more people than our 300 million people are the ones that are really, really at risk. Good question, though. I wish I knew an answer. If we knew that answer, then we'd say we have to pick this number because we can't afford to do anything else. But that's the problem. This is a critical thinking problem where it is our social conscience and it is our reasoning that will decide. Every environmental problem is the same way. We decide what we can afford to do because you can never get perfect. You can never get clean water all the way. As the commercials talk about now, there's lead in your water. Yeah, there is lead in water. And there's also mercury and there's also cadmium. And we set the standards where we can afford it, not where it's absolutely clean. And the air you breathe and the amount of carbon dioxide that we can live with and the climate change that produces are public policy decisions. Please, sir. I think that's a great question, but it has been time to time in the American discussion. For example, one of the things that we figured out to help control AIDS in Africa was educating women who then have lots fewer kids and have more safe sex and understand that relationship that both reduce the populations in that part of the world and reduce the levels of AIDS that was being seen there. But we don't do that anymore. That's a decision we have made. And it's in the developing world. You know, it's a political, religious, quagmire that we get into, and we stay away from that. But I think it's a great question. Okay, I need to quit because it's the appointed time. I will stay here and answer any questions and have discussion as anybody else that wants to, but I don't want to hold people up. They got places to go, people to see.
We try to honor the 12 to 1,
Yep.
and it is 1 o'clock. I'm sure there are many more questions people may have. Dr. King has agreed to hang around for a while if you want to visit with him. And I thank you for coming, and we'll see you next month.
Thank you. Thank you.